So x is a random variable with variance 1.8 and the mean equal to 14. Y is equal to x minus mu x. Z is as shown here. Okay, that is z is equal to, again you can see that it is average. Okay, this is average. Okay, further to that, this y is x minus mu x. This y is x minus, where yi's are IIDs. What are the mean and the variance of z? So what is given is not the variance of y, but is the variance of x, and the mean of x is given where y is equal to x minus mu x. Okay, where y is equal to x minus mu x, and further we are taking the average of all those y's for z. So mu x is 14, sigma x squared is 1.8. So mu y will be that is expectation of y will be expectation of x minus expectation of x. So mu y will be mu x minus mu x. Expectation of x means mu x. Mu x minus mu x will be equal to 0. Then sigma y squared will be equal to the variance of x will be equal to the variance of y will be equal to the variance of x. If you take variance on both the sides of this, you will get here variance of y is equal to variance of x minus variance of mu x. Variance of mu x, mu x is a constant value. Okay, mu x is mean, so it's a constant value. Variance of the constant value will be equal to 0. So variance of y will be equal to variance of x. Mean of a constant is constant itself. Please remember this. Mean of a constant is constant itself. Variance of a constant will be equal to 0. Variance means the one which varies. Constant does not vary. Constant remains same. Constant does not vary. Constant remains same. Hence, variance of a constant will be equal to 0. But however, mean of a constant will be the constant value itself. Okay. Expectation of C, where C is a constant, will be equal to C. Variance of C, where C is a constant, that will give us a value 0. Okay. So variance of y will be equal to the variance of x itself. Okay. So that's why we will get here, same value 1.8, but the mean of y will be equal to 0. So going on the same lines, now we have the z as the average of 100 y's. Average of 100 y's. So if you take that, then the mu z will be equal to mu y equal to 0, because we are talking about average. Whereas the variance of z will be equal to the variance of y divided by the value, which is the number of samples. 100 samples are there over here, therefore we need to write the same n over here, 100. Okay, that will give us the value, which is 1.8 divided by 100, and that is 0.0180. 0.0180. Now let us go for the next problem, which is 59. The random variable z is uniformly distributed between 0 and 1. This is uniformly distributed random variable for z. The random variable of y is obtained from z as follows. Y is equal to 3z plus 5.5. And we take 100 independent realization of y are averaged. That is u is equal to 1 by 100 of this. Estimate the probability u less than 7.1. If 1000 independent calculations of u are performed, approximately how many of these calculated values for u would be less than 7.8. Okay. So the mean of y will be equal to, mean of y means expectation of y will be equal to expectation of 3z plus 5.5. That is 3 expectation z plus, expectation 5.5. Expectation 5.5 will be 5.5, and 3 into expectation of z. Expectation of z is mean of z, that is 0. 3 into 0 plus 5.5 will give me the value. 3 into 0 plus 5.5 will give me the value, which is 5.5. Okay, so therefore mu y will be equal to, okay, mu z, he has given it as okay, sorry, So this is, I think, I'm confused here. It is uniformly distributed between 0 and 1. I assumed that 0 is the mean and 1 is the variance. It's not so. Z is uniformly distributed between 0 and 1. So for a uniformly distributed function, the mu z value will be equal to the average of this 0 and 1. That is half, and the variance will be 1 by 12 for a uniformly distributed function, which is something like this. Mean will be half and variance will be 1 by 12, and that is what is written over here. So the expectation of y, or mu of y, will be equal to 3 mu z plus 5.5, and that is what is written over here. So mu z is 0.5 plus 3 into 0.5 plus 5.5 will give us 7.0. Okay, and the variance of y will be equal to 3 into 3, variance of 3z plus variance of 5.5. Variance of 5.5 will be 0. Variance of 3z will be equal to 3 squared variance of z squared. 3 squared variance of z squared. You can try to write it, expand it, and try to solve that. You'll definitely get it. Okay. So variance of y will be, variance of y means, variance of y, should remember that it is equal to expectation of x squared minus expectation of x whole square. Variance of x will be equal to, okay, or for that matter, variance of z is equal to, or variance of y is equal to, okay, expectation of the squared term minus the square of the expectation of that value. Okay, so if you substitute that, then you'll get this as 3 squared, and that will give us 3 squared sigma z squared. 3 squared will be 9. 9 by the what you call sigma z square is 1 by 12. Therefore, it will be 9 by 12. Okay, so now this is for the y, which is only this. Now going further to that, then u is the average of 100 values. Average of 100 values. U is the average of 100 values. So going in that way, then mu u is equal to mu y, because average, that is equal to 7.0. The sigma u, now he is writing here the standard deviation. Please check this. This is standard deviation, not the what you call variance. If you take variance here, then definitely we need to consider this value divided by n. The value of n is 100. Okay, the value of n is 100. So the variance will be 9 by 12 divided by 100. That will be 9 by 1200. And the standard deviation will be root of that 9 by 1200. That will give us this. Okay, this is standard deviation. So first, what he wants, A is probability of u less than 7.1. And this is nothing but the cumulative distributive function for 7.1. This cumulative distribution function for 7.1 can be written as characteristic function, where characteristic function will be written as mu of whatever the value here, that is 7.1, minus the mean value of the mu u divided by the variance. No, it's not the variance, rather it is the standard deviation. Okay, that is why the sigma u is written over here. This is standard deviation, 7.1 minus mu x minus sigma over here. 7.1 minus mu minus sigma. Mu is 7.0 for u and sigma is 0.8666. So if you see this in the plot, okay, for the characteristic function, you will get here as 0.8759. Okay, you will get it as 0.8759. Now, the second one he's asking is 1,000 independent calculations of u are performed. Approximately how many of these calculated values for u would be less than 7.1? Okay, that will be straight away. This should be the value here should be multiplied by the 1,000 over here, and that will give us 876. That will give us 876. Okay, so the result will be just 1,000 into the value of the characteristic function. Okay, so if you have any doubts, you can ask.